Everybody. So my name is Craig Dodds. I'm one of the chief architects responsible for security at Juniper. And today we're going to be talking about combining Office 365 and PowerShell for covert command and control within Office enterprises, I should say. In the interest of time, I cut out my biography slide, but the Cliff's Note version is I've been at Juniper for a little bit over a year at this point. Prior to that, I spent about 5 years at IBM Security. And before that, I spent many years at Checkpoint Software and Nokia. So, moving on. First and foremost, our agenda, we need to discuss why Office 365 makes for ideal C2 infrastructure. After that, we're going to discuss how PowerShell fits into this, specifically around the new PS drive command. And if you're not familiar with that, you can make a pretty quick guess, but it's responsible for mounting local and remote file systems within PowerShell. After that, we're going to go through a simple 4-stage proof of concept. I've tried to keep all the examples as simple as possible, so even those of you who are not familiar with PowerShell necessarily should be able to follow along. After that, we will talk about some mitigation strategies. And after that, of course, we're going to come at it from a red team perspective and discuss evading detection, primarily focused on sandbox evasion, as well as our final demo. All right. So first and foremost, it's important to talk about Office 365 adoption rates. First and foremost, of course, credit goes to SkyHigh for the data that they collected last year. But as you can see, for any enterprise that's got more than 100 users, adoption rates are quite high. Up to 80% in some cases for certain services such as OneDrive. And in the case of our specific talk here, we're focusing on those enterprises who have adopted both OneDrive as well as SharePoint. So, getting into it, why it's actually interesting for command and control. As you saw in the last slide, the vast majority of enterprises are already permitting traffic to Office 365. Hopefully it's all TLS at this point. But if you're going to be using the service, you can make a really easy assumption that the network infrastructure and security infrastructure that's in place today has access to this already. And of course, we can take advantage of this, but larger enterprises, due to the volume of their traffic, have enrolled in a service called ExpressRoute that Microsoft offers. And with that service, you actually enter into a direct peering agreement with Microsoft between your premise, such as a data center, and Azure. And you can buy these pipes. Sorry. You can buy these pipes in significantly large quantities. So most Fortune 100s, if you look at it, they've at least got a single 10 gig link into Azure at this point, if not multiple ones. So due to the aforementioned volume of traffic and generally associated level of trust, most enterprises today are not decrypting any traffic, at least from a TLS perspective, going to Office 365. They may be looking at email, but generally not web traffics. So we can, of course, take advantage of this. Another minor advantage, of course, of using Office 365 is it can be considered an out-of-band method of attack. So when you're interacting with your target is communicating with Microsoft's IP ranges and not necessarily your own. Not to say Microsoft isn't monitoring what you're doing on their service, but your target generally will not see what IP you're coming from. And this is really one of the focuses of the talk rather, but when you're mounting, as an example, a SharePoint drive on a target, which is something you can do and we will get into it on this talk, you can do it in a way that's invisible to almost any service that the user or the admin is running. So when you mount one of these drives, you can have a remote file system point on your target, but it's invisible to File Explorer, WMI, COM, and anything built on .NET frameworks. Like NetUse as an example. So it's extremely difficult to even track the usage of these things, let alone for a typical end user to identify that, hey, I've got this remote drive on my system. And of course, if you are subscribed to DLB solutions, assuming they're even able to identify that a PowerShell drive has been mounted, generally speaking, they don't view network storage as being outside of the enterprise. So you're able to transfer things, assuming you're coming at this from a data exfiltration use case. They generally don't see it as being an issue whatsoever, of course, because who mounts drives outside of their enterprise? That sounds like a bad idea. So Microsoft, of course, saw this coming. So even if you're able to figure out how to mount a remote SharePoint drive, as an example, you don't actually get read or write access to that drive. So if you want to actually be able to use that drive, you need to figure out a way to fetch a SAML token from Office 365 before mounting that drive. And as an example, I've mounted a drive here, and I'm simply trying to echo test into a test file, and I'm presented with an error. So I'll read this for the guys in the back. But basically all it says is when you try to write a file, you get access denied. Before opening files in this location, you must first add the website to your trusted sites list, browse to the website, and select the option to log in automatically. Sounds easy, right? So this is where PowerShell comes in. So fortunately or unfortunately for us, Microsoft has spent a lot of time developing the libraries in PowerShell so that it can interact with and control Internet Explorer. And we can use this, of course, to load up portal.office.com. We can avoid any single sign-on technologies, of course. If a target is already using Office 365, generally speaking, when you navigate there, you'll be automatically logged into their account, which will, of course, defeat our purpose. And then we can enter credentials, click on a few buttons, and we can do all of this without launching Internet Explorer in a way that the user can see it. So if they're staring at their desktop and you do this, nothing pops up. So an important part of the talk, of course, but if anyone can come up with a legitimate reason for being able to set IE visible to false, I will buy them a cookie. You can find me after. So phase 1, of course, for our first proof of concept is being able to get that SAML token, since we can't do anything without it. And this is just the site that you, or the page that you see when you actually navigate to portal.office.com. You actually get redirected to login.microsoftonline.com. And then a very important checkbox, this was actually what triggers that SAML token to be pushed, is the keep me signed in button, of course. And we're using bad guy as our user. So I'm going to take a quick drink. This is some, again, very simple PowerShell. We've got clear text credentials, of course, since again we're trying to keep things simple. We go through initially killing Internet Explorer so we can manipulate what we need to. On line 5, line 7 through 10 is using run DLL32 to simply clean up forms, passwords, and cookies, which is generally where SSO lives. 12 will instantiate IE. 13 is our lovely set IE visible to false, which means it's not going to pop up for the user to see. The next couple lines actually navigate to the URL, and we sleep while Internet Explorer is loading it to deal with latency. But then, thankfully for us, we've got the ability to search for specific element IDs within PowerShell. So we look for specifically our user ID input text, our passwords, and then the most important one is keep me signed in as a checkbox. We set it to checked and true. And then we actually have to go in and click on the buttons, of course. So there is some filler text that you will see. Basically sample usernames that you actually have to click on to delete. And then we click on sign in. So this is our first demo. It's very simple, of course, and we've set IE to be visible so you guys can follow along with what's going on. But we load things up. You can see the sample text here. So someone at example, you do have to click on that, unfortunately, for it to go away. But we're just going to copy paste in the PowerShell that we were looking at before. We can see IE pops up, we delete our cookies, and it takes about 1 to 2 seconds for this to happen. And we're presented with bad guys SharePoint drive. Easy enough. So phase 2 of what we're trying to do here, of course, we need to then add SharePoint into our trusted sites so we can mount the drive. And then, of course, most interestingly is actually mounting the drive itself. So again, we have to define some credentials to use for our SharePoint drive, and they do need to be stored as a secure string, which is why you see that up there. But generic domains, or generic credentials I should say, then we actually have to go and add some registry keys so that IE recognizes the place as a trusted site. I'm assuming most of you guys know how to do this at this point, but basically all it is you're setting a location, you're creating a key, and then depending on the OS version, so in Windows 10 you'll see this pop up as red text, but you may have to hard code your subdomain in there, in this case bad domain. Windows 10 you don't have to do that, of course. And then we just add some D words. So generally speaking, you still only need to add HTTPS here, but we've added HTTP and a wildcard just in case there's some strange web proxy downgrading or something else is going on the wire. And then of course 16 and 17 are the root of what we're trying to do here, but mounting the drive itself. So new PS drive is pretty simple to use, and by default it will mount a temporary drive, which disappears after the shell has been closed, but it's also harder to detect, of course. So for our purposes, that's what we're going to do. We specify the name, so we've gone with J drive. We set the provider to be the file system, of course, and we specify the root directory. Now, it's a long string, of course, but we've specified eviler-mysharepoint.com, and the most important one is at SSL, of course, so it gets encrypted. Excuse me. And then we specify root, personal, and then the full username and domain, and we specify documents as the root directory. And then we feed in the credentials. It's not too difficult, but we're going to have another demo here of just going through this quickly. And as we mentioned before, of course, in File Explorer, most users are going to interact just simply by clicking on my computer, my PC, depending on the version, and they're going to see devices and drives pop up first. And of course, you're going to see that this is not present. So we're just looking at the zone map. Obviously, nothing is there right now. We're going to show get PS drive, which is a way to actually display PowerShell drives. But of course, we can see nothing is mounted at all other than C and D at this point. So we're going to paste in the PowerShell that we were looking at before. There's the red text you would expect. But now we can see that J has actually been added, and we can see the full path there as it's on SharePoint at SSL. So we're going to CD into the drive, and we're going to validate that we now have write and read access to the directory. So nothing's present right now, but we're going to echo in this is a test into a test file, and we're going to see that it works. So we can see we now have a usable drive, thankfully, and we can see the full path there if you'd like to look at it. And we'll validate that we've also got read access, which isn't necessarily implied, but we can just do get content on the file, and we see that this is a test. So checking out File Explorer again, we can see, again, refreshing it, the user sees nothing. They are completely unaware that there's a drive now mounted on their system. And of course, going back and refreshing, we now see SharePoint with all of our D words that we would expect. All right, moving on. So phase 3 is actually doing something interesting, of course. Again, in the spirit of keeping things simple, we're just simply going through, we're identifying all files in the user's directory. We're quote unquote stealing all of their PDFs recursively within their user's directory. And then for the C2 portion of things, we're going to go and run some commands. So today's commands.txt. And most of you are probably aware of this already, but PowerShell by default prevents you from running PowerShell scripts on a default install of Windows. So there's many ways around that specific execution policy restriction, but the simplest and probably my favorite is simply reading in those commands from, say, a text file and piping them into PowerShell. That's good enough to get around that restriction. So I'm going to have another simple demo here. We can see that we're currently in our SharePoint drive. We're going to paste in the commands we were talking about earlier. And we can see it slowly go through and identify all the files and identify and upload all PDFs into that SharePoint. So this is coming at it from the data exfiltration perspective, of course, which is most concerning to enterprise customers, of course. It's not the only thing you can do, but it's an example. So we can see we've got current files, we've got financial statements, et cetera, et cetera. Just a demo. And we can see that we've now popped calc and we've loaded up blackhat.com. Nice and simple. So I guess for the purposes of the talk, obviously that's nice, but we need to look at it, weaponizing it a little bit. So we've gone with something simple again, and just gone with a macro-enabled Word document. And doing this, just using Unicorn. It's one of my favorite tools, of course, written by TrustedSec. But it's probably the easiest way to take some raw PowerShell that you've developed and instantly convert it into something you can paste into VB Editor and use as a macro. It's very simple, and we'll show you how to do that. As you'll see on the next slide, at least using this method, most detections for endpoint tools are relatively non-existent. And Unicorn, although it's not overly effective with sandboxes, it does try to evade them by delaying detonation until after the document's been closed. So you can try to remember this hash for later, but it starts with C10, ends in F83. But at the time of submission, our quote unquote totally legitimate document was only detected by 4 out of 58 vendors. And it's likely that the 4 that did detect it identified a generic string that Unicorn uses as an error message. So if they look for that, they can usually find Unicorn quite easily. And again, for those who haven't actually seen the output of what Unicorn creates when you generate some PowerShell, or feed it PowerShell, I should say. This is just what it looks like inside of VB Editor. And you see that generic string down here. Hopefully, yeah, you can see my mouse. You've got the document appears to be made on an older version of Microsoft. Please have the creator save to a newer and supported format. So frankly, that works on a lot of users, of course, but you can write easy signatures to look for that string. So if you're going to do this in a real pen test, of course, probably change it. So this is the final demo for the first proof of concept. We're looking at the attacker's machine, of course. So this is on SharePoint. And we've just refreshed it, and we're going to look at today's commands. Of course, this is completely arbitrary. We're just popping calc in this case and loading up IE. But if you're doing this for real, you'll probably look at adding some type of persistence mechanism or something else that will allow you to do this on a recurring basis. So looking at our PowerShell, you'll notice that it's called compressed. Instead of having every line generate a carriage return, VB Editor is very particular about how many carriage returns are present in the file. So you can actually compress, say, 100 lines of PowerShell like what you see here down into one line simply by deleting the carriage returns and replacing them with semicolons. There is a very low limit when it comes to carriage returns in most macros. So we can see what it looks like. And we're just feeding this into Unicorn. It's very simple. So basically you just specify that what PowerShell you'd like to use. You specify that you want to generate a macro, and you create your character limit of 500. And that is all you have to do to now get PowerShell attack.txt. And that is a fully working macro with whatever PowerShell you've given it. So that's what it looks like. It's important to note, depending on what application you're targeting, you may have to change the subname. So in this case, by default, Unicorn adds an underscore between auto and open. This works for Excel, but it does not work on Word. You actually have to delete the underscore and make sure the macro is named correctly as well. It's a little finicky, but just so that you're aware. All right, so moving on. So we're now looking at corporate drones workstation, and we're going to need to use a bit of our imagination and assume that he's been the target of some type of phishing attack. But totally legitimate document has now ended up on his desktop, as we can see there. And unlike most users, more for the purposes of the demo, we've got Wireshark running here with a search query specifically looking for SSL handshake extensions for the SNI of portal.office.com. And this is just to display what your security infrastructure is going to identify on the wire when these attempts are made, assuming you're not doing SSL decryption. So we'll come back to that in a minute. And we're just going to show the hash here so you guys can try to remember or recall what it was on the last slide. But it's C10, F83, and yes, you can do this through PowerShell, but this is easier to read at the back. Anyways, moving on. So we're going to actually execute the document, and as you would expect, Word has built-in macro protections. So I actually, before it goes, I lifted this from an actual sample of malware, which I guess is a credit to Norton, but end users find this very trustworthy. And for those at the back, it simply says, the document's been secured by Norton. To view this protected document, click Enable Content. And this type of message works on a very large percentage of end users, unfortunately. So just clicking it, we see that generic message pop up saying older version of Word, try to get a new one from your sender. And pressing OK, of course, from the user's perspective, nothing happens. It goes blank, as you would probably expect. But jumping on Wireshark and looking at the wire, we see multiple requests to portal.office.com. And that's all you see. So if you are not looking at doing SSL decryption between your enterprise and Office, that's what you see. It's very difficult to identify this as being any type of malicious behavior whatsoever, especially if it's being run once. So moving on, of course, calc eventually pops, as well as Black Hat coming up. And we can see, moving back to the attacker's machine, as you would probably expect, the files that we looked at before have now been uploaded into SharePoint. We can click on the desktop. We've got it named appropriately for that specific user. Go into uploads, and we can see once it loads that all of the files that we would expect to be there are now there. And it's surprisingly easy to do this, as you guys have seen. All right. So, as you would expect, just a list. But again, it's a demo, it's a proof of concept. You guys can use your imagination and think of what an actual pen test or something worse might be conducting here. So, for the blue teams in the room, of course, the easiest way, of course, to come at this is from the network side, but it does require you to decrypt TLS on the wire, which can be, of course, expensive. If you want to look at actually blocking this in line instead of dealing with it as kind of an incident forensic perspective after the fact, you can create custom signatures with most products that identify either your Office domain or negate that so that any other domain other than yours gets dropped immediately. You can do, of course, endpoint log forwarding. You can pick your product of choice. Obviously, Windows has built-in utilities to do this as well. But just creating alert every time new PS drive is used, or doing bulk analysis, you can reach out through WMI or whatever you'd like and just run get PS drive and look at the outputs, of course, and see if there's SharePoint drives that are mounted, and if there are, is that okay? This is more suggestion for forensics, of course, but network devices, not just firewalls, but anything with NetFlow or something that's keeping track of the byte counters on the flows themselves can identify extraneous external uploads, of course. So in a normal connection, you'll see a disproportionate amount of bytes allocated to the server side, of course, since the client is requesting data. But in an external upload, of course, your client maybe has a 10-to-1 or 20-to-1 ratio with the amount of traffic it's generating versus the server. So they do stand out quite well, again, for data exfiltration. And of course, depending on how you're coming into the network itself, you can defend against a lot of this using some type of sandbox, of course. Behavioral analysis does work sometimes. And of course, email is the primary vector that we're concerned about here. So, what about sandboxes? We've kind of already touched on this, of course, but this specific technique, since it's just generic PowerShell, detection rates are pretty low, especially for static analysis engines and obviously signature-based. Again, we've kind of touched on this as well, but most sandboxes do not like when you're modifying the registry and interacting with the browser in some way, shape, or form. So, what can we do about sandboxes? And before we get into this, I'll just give you a really quick primer on sandbox evasion, I guess. So, initially it started out, there were a couple different camps on how to do this, but primarily focused rather on sleep functions. So, if they're able to outsleep the sandbox, of course, given that most sandboxes have a hard-coded timer set, whether it's 5 minutes, 10 minutes, they have a limited amount of time to determine that a file is actually malicious or not. And of course, using sleep is a very simple way to sleep longer than a sandbox. Looking at VM detection, just generic VM detection, system properties, how many CPUs you have, how much RAM, if you're using, say, a pair of virtualized storage drivers, anything like that that gives away that the VM's there, VMware tools, VirtualBox add-ons, etc. There's many, many ways to determine that you're in a VM. But as an industry, we've overcome almost all of these, of course. Then we get into more complex attackers, of course, that have started fingerprinting individual vendor sandboxes, of course. So it should come as no surprise, but if you are building a custom sandbox, there is going to be some sort of artifact from your technology on that OS, whether it's DLLs, kernel hooks, specific drivers. There's something there that probably gives it away that it's a sandbox, but again, we can do pretty well, especially if we've gone to something like bare metal when we're detonating these payloads. After that, of course, this one's still a little hard to overcome from a sandbox perspective, but doing generic human behavior analysis within the VM itself is still quite effective. Just looking for, say, ensure the user has scrolled through, say, 50 pages or check their browsing history, make sure it goes back 6 months and that they've bookmarked website X is still a pretty effective way to get around sandboxes. The last two are more concerning, of course, but a lot of vendors' technology requires a sandbox to be vulnerable to that specific exploit for them to be able to detect it's been executed. So an intelligent attacker can make an assumption about their target saying, hey, I know this enterprise's patch management schedule usually takes, say, 12 months to catch up. If I pick an exploit that's 18 months old, I should say, and detonate it or check its vulnerability status, rather, I can make a reasonable assumption that if it's vulnerable, I shouldn't be detonating my payload because I'm probably in a sandbox or some type of honeypot. That one's problematic to deal with, and arguably the most problematic to deal with, at least as far as I guess a global sandbox issue, is just delaying execution through generic routines. So the best example here is computing pi to 10 million digits on a slow sandbox. That can take days. And the sandbox doesn't necessarily view that as malicious, especially if you, say, apply some type of nice level where it's not consuming much CPU. If it doesn't detonate until it's computed pi, it's very, very difficult for sandboxes to identify this type of thing. But we're working on it. So, what else can we do? The probably most effective method that I'm aware of right now is designing malware that places malicious payloads in interesting locations that are likely to be detonated by the end user, but they lack the ability to detonate themselves completely. So, I know that's kind of nebulous, but as a specific example, as a malware author, you can look for recently accessed files, such as, say, the last 10 modified documents, and make a reasonable assumption that a user will come back at some point and try to modify them, whether it's a grocery list, a presentation, doesn't matter. If you embed something into those files, you can make an assumption that it will get triggered eventually. And of course, the sandbox has a very hard time dealing with this. So this is just a quick example on how to find your last top 10 modified documents and then sort them. And then, of course, most usefully provide the full path to them. So we've got a couple options if we're going to try to do this through a sandbox. Easy mode is simply outright replacing those files with malware. Same name, same extension, same icon. Sometimes works, but honestly it's not that effective. Hard mode, which works quite well, but it does require some permissions, or at least making some assumptions about the environment before you launch it. But it does, you are able to inject macros into existing Word documents and then exit. And of course the sandbox will not follow up and then detonate that Word document. It just sees that, hey, you added VB script somewhere. That's not really a problem from my perspective. Or my personal favorite at the moment, replacing those files with shortcuts that then point to a malicious second stage in a whitelisted location, such as Office's trusted locations, which override a lot of the generic protections, such as macro, for your files. So instead of getting that enable content pop up, it just automatically detonates once it's launched. And this is surprisingly easy to do. So, as you can assume, since you're not distributing malicious payloads in your first stage, you do have to have some way of downloading that malicious second stage to the endpoint. And the easiest way, of course, is web client, although, as many of you may be aware, you'll generally get flagged by an AV vendor because it's just a generic Trojan downloader. This is pretty common, of course, so there are lots of other methods. But if your sole purpose is getting that Office 365 drive mounted, because frankly, once you have a local mount on a file system, your job as a pen tester becomes immediately easier, almost infinitely easier, because you can interact with it using normal user commands instead of fetching and doing other nefarious things. But if you need to get that and you don't want to use web client, you can use reverse shells and paste it in manually. You can do tunneling through ICMP, DNS, take your pick. Just get it there somewhere. Somehow rather. And again, as kind of alluded to in the last slide, the most effective place to put this, assuming you're sticking with Microsoft Office documents, is to put it into one of the trusted locations. They are not protected locations, but they are whitelisted. So when again the user opens up that shortcut, it's going to link to the malicious file, which no longer has any of the traditional protections that Word provides you. So I know, I know I said I would keep it simple, and this is a lot of PowerShell on the screen, but it's still quite simple. So again, we're looking at our top files on the top, and we create two arrays. One of them was originally the normal files, so the top 10 documents, and then we create another array that simply replaces our docx's with shortcuts, so LNKs. And then we have a simple for loop, so for every file in that LNK array, we create a new object, which is a shortcut of course, and we point that to our, again, totally legitimate document, keeping things consistent, and that resides in that trusted location, which is app data, roaming, Microsoft Word, startup, etc. Saves it, and then it sleeps for 1 second to ensure that all of the files don't have, I guess, similar or identical timestamps. And after that, on so line 18 down, basically it's just fetching the file. It is using web client just to show you a different way of fetching the file, but it's still hosted on SharePoint, and you excuse me, sorry. Still good, I think. All right. The URL is all there. So you can actually generate that URL by doing get link or copy or share through one of the GUIs that you have. The only minor modification you have to do is replace guest access with download.asp. So generically, if you use the normal link, it's going to open up a browser and it's going to navigate to the online portal for Word and let you maybe have read access or write depending on what you generate. So that's the full link, of course. Web client downloads it, and then we make an assumption, of course, that 7-zip is present on the endpoint, but we're doing that so that we can have an encrypted payload. Because frankly, most tools, even if they're able to intercept that web client request, they don't necessarily alert you if they're unable to extract an encrypted payload. So in this case, we've got latest forms.7zip, innocuous sounding, and then we basically feed in the password of Blackhat 2017, password 12345 on line 30 down here. And then we extract that into our trusted location. And then we clean up and delete the original files. Excuse me. All right, so this is a bit of a prettier demo. But this is Corporate Drone again, and he's the subject of a phishing attempt, which simply reads, "Hello Corporate Drone, as discussed, please find my cover letter attached to the email. Thank you for your consideration." Very generic attempt, of course. And then we've got our original documents on the right-hand side. And we can see the path, of course, is just C, username, documents, where you would expect it. So Corporate Drone's maybe learned a few lessons over the last couple months and thinks, hey, this is pretty suspicious, maybe I shouldn't open it. So he's going to run it through Defender, and then he's going to try a sandbox. So he's going to extract it to his desktop, which arguably is kind of dangerous anyways. But he's going to run it through Defender, and we're assumingly going to go around it just fine. Scanning the whole desktop to be certain, and Defender's not flagging it. So he's going to try something else. And we're going to use Cuckoo here. And just an immediate shout out to the Cuckoo guys. It's a fantastic product. Really recommend checking it out. And if you aren't aware, most major commercial sandboxes are actually leveraging Cuckoo as well for at least part of their infrastructure. It's a very nice, easy to use tool. So here he's saying, I'm going to specify that it's a document and see what happens. And for the, I guess, save on time, we've sped this up, of course, but the report comes out, and immediately you can see that the threat level of the file is not considered threatening. It's 1.8 out of 10. It's not a perfect analysis, of course, but generally speaking, anything under, for depending on the product you're looking at, 7 or 8 will usually get through. But anyway, so he's going to go and look. You can see screenshots. You get a full behavior breakdown, but he sees that, oh hey, it looks like there's a version issue. It's the same error we saw with Unicorn from before, of course. But he's going to keep looking. And he clearly knows enough to be dangerous, but he hasn't really learned that launching PowerShell out of Word is probably a bad thing. But it's there. Of course, it drops some files as you would expect. But frankly, it's not doing anything bad from the sandbox's perspective, so he thinks it's okay. So he's going to go and open it. And we're going to see what we probably expect here. We enable content. It's a macro, right? It's not interesting. And then we press OK, and then immediately we see our documents have suddenly transformed from documents into shortcuts. And of course they look like docms. You can change that if you'd like. But now they are only a shortcut pointing to that malicious file. So you can see when you open the path, specifically it's sitting in that app data trusted location. So when you go and click on it, of course he wants to work on his grocery list. You don't actually open a grocery list, you go to your malicious file, and in this case you've noticed you did not have to click enable contents. So it is a very effective way of getting a malicious payload detonated without obviously worrying about the user clicking on things. So what is next? So this is a lovely proof of concept, of course, but you can't necessarily take it home. Obviously, if you have a reverse shell, you can copy paste this in, or just copy from GitHub that I'll give you links for, but having a tool that does this for you would be nice. So specifically, working with Empire, rather excited about it frankly, on a Office 365 lister module, very similar to the module that was just released for Dropbox. Excited about it. We can talk about that after if you'd like. After that, of course, logically, Metasploit makes the most sense. I'm taking feedback right now on what you guys would think is useful in this case, but it's going to be a generic kind of proof of concept initially. And then most importantly, just due to the time constraint that we had here, we didn't really have time to talk about the APIs within Office 365, but being able to leverage those within the tools would obviously make a lot of sense. Right now, the APIs are somewhat limited when it comes to SharePoint. They're almost non-existent. But OneDrive does allow you to interact with the file system as well as add and remove files, so that can, of course, have a lot of value. So, closing remarks. I think I've kind of beat this to death at this point, but you need to decrypt your TLS traffic. It's unfortunate, but it's a reality, especially if you want to intercept this communication on the wire. It's fine to do incident response after, but this will actually prevent these types of attacks before they occur. So again, you can monitor for PS drive usage, or you can deploy signatures if you're decrypting. The signatures are quite effective at stopping this, of course. But it does come with a resource penalty on your network appliances. So this is more of an industry-wide problem, I suppose, but sandboxes need to get better. Only basing your analysis on the first file in the chain, not necessarily looking at all files and how they behave, is kind of a flawed approach, frankly. You do need to do secondary or tertiary file analysis to detect this stuff. And of course, inspiration. None of us really work in a bubble here, of course, but the initial inspiration came out of a talk that George and Dimitri were doing from CrowdStrike back at RSA in February. And they were talking specifically about techniques that bears and pandas were using. But for this talk, of course, this came out of their Cozy Bear analysis that was using NetUse and the public version of OneDrive. So it's a little different, of course, and it's much more easy to block in an enterprise than Office 365, but it's a similar approach, of course. And then, of course, Kaspersky Labs has a very similar write-up on Cozy Duke. So as far as references go, you guys don't have to write this down. The slides will be up later, of course, but all of the PowerShell that we used here is available. And that's it. Thank you.